Welcome to The Explainer. Today, we're taking an absolutely incredible visual journey spanning hundreds of millions of years to explore the absolute latest discoveries in science. I gotta say, I love this format because we get to break down some seriously complex research into clear, undeniable visuals. Let's get right into it. So what do a 520 million-year-old fossil and Pluto's shrinking atmosphere have in common? At first glance, absolutely nothing. But they both represent the absolute cutting edge of what science has unearthed in literally just the past 7 days. Okay, let's dive into this. Here's our roadmap for today's explainer. We're going to start with ancient life unearthed, move right into Ice Age artistry, explore some fascinating quirks and threats of nature, and finally push out into space and AI frontiers. Section 1. Ancient life unearthed. Just to ground ourselves right off the bat, take a look at this timeline. The sheer, almost incomprehensible scale of prehistoric time we're dealing with here is wild. We're going to hit 3 massive points: 520 million years ago, 237 million years ago, and 75 million years ago. It is genuinely fascinating how just a single tiny discovery in the dirt can completely rewrite our entire understanding of evolutionary biology. Let's start way back at 520 million years ago, right in the early Cambrian period. Researchers in South China just discovered a tiny fossil named Eoseras, shanksyansi. Now, this is a huge deal because it extends the known history of cephalopods, the group that includes modern octopuses and squids, by nearly 20 million years. And get this, through micro-CT scanning, they found something amazing: a siphuncle. It's basically a primitive segmented tube that connected internal shell chambers. It acted like a built-in buoyancy tube, helping these ancient shelled creatures regulate how they floated in the water. Let's move to our next timeline stop and see how this builds. We jump forward to the Middle Triassic period, about 237 million years ago, and the contrast is just wild. We go from Eoseras, which was literally microscopic at just 1 single millimeter long, to an absolute beast discovered in Svalbard in the Arctic, Arctobatrachus odensus. This thing was a massive, 2-meter-long apex predator amphibian. Now, what's really interesting about this slide is the sheer nightmarish quality of this creature. Picture this. It had an almost perfect semicircle for a skull, and it was just packed with closely set rows of large fangs positioned right behind smaller teeth. It gets weirder, too. This member of the Paleontological family was actually first found way back in 1948. It was excavated in 1985, and yet it is only just now being fully described as the spectacular giant predator of its ancient ecosystem. Finally, we hit 75 million years ago in the late Cretaceous. Meet Dinosaur robust. The crazy part here? Scientists identified this new, relatively large carnivorous troodontid dinosaur entirely from a single, incredibly thick, isolated left frontal bone found in New Mexico. It really reminds us how just one single fragment left in the dirt can completely alter our understanding of ancient North America. Moving on to Section 2, Ice Age artistry. Jumping much further forward in time to the history of our own human ancestors in Europe, we find artifacts that are just beautifully mysterious. During excavations literally just this year, in 2025, archaeologists working in a cave in Germany uncovered these stunningly detailed bird carvings. They were crafted 40,000 years ago out of Mammoth Ivory. And what makes this even more incredible is the historical weight of this specific location. This exact same cave previously yielded one of the world's oldest musical instruments, a flute made from a vulture bone, and the earliest known Venus figurine. And despite being tens of thousands of years old, these new figures are instantly recognizable as birds. One is depicted resting, and another, which they think is a ptarmigan, is spreading its wings. But why make them? The exact purpose of these carvings remains a total mystery. Researchers speculate they might have been crafted to help hold on to memories, or maybe they played a role in ancient rites of passage. Just think about that profound human element for a second. 40,000 years ago, someone sat down with a piece of mammoth ivory to create something lasting, recognizable, and just really beautiful. Section 3. Quirks and threats of nature. Let's step out of the ancient past and firmly into the modern day. Because science isn't just about looking backwards, right? It's about understanding the complex and sometimes very urgent biological mechanisms happening around us right now. For example, did you know insects can smell with their wings? It sounds like science fiction, but a fascinating new study investigated the tobacco hawk moth. Researchers actually hooked recording electrodes up to the moth's wings to prove this. They discovered that small pores in the wings can physically detect chemical signatures. The wings literally express genes that encode for chemical receptors. This absolutely bizarre mechanism allows the moths to identify the specific odor of nightshade plant leaves, which is exactly where they like to lay their eggs. But as we shift our focus from the skies down to the seas, the tone shifts a bit too. 1,500. That is the massive estimated number of cargo ships that have been sitting anchored and completely idle in the Persian and Arabian Gulf since late February. So why is this such a big problem? It leads to something called biofouling. When ships don't move, their protective anti-fouling coatings are compromised. This allows marine microbes, algae, and invertebrates to rapidly colonize the hull. Now, the International Maritime Organization actually recommends vessels take action to manage this if they've been idle for just 18 to 30 days. But these ships, they have been sitting for months. And with intense economic pressure to get cargo and crews moving again once trade finally resumes, taking the time for a proper cleanup is highly unlikely. And this brings us to a stark warning from marine biologists, who are calling this a potential bio-invasion super spreader event. If these ships resume their global trade routes without cleaning their hulls, they could spread non-indigenous species globally. Even worse, these biofouling communities act as reservoirs for foreign parasites and pathogens, including ones that can cause devastating epidemics in commercially important species. It's a very real-world crisis happening right now on the hulls of our global fleet. Let's turn to our final chapter, Section 4, Space and AI Frontiers. Let's blast off into outer space and push the very limits of biotechnology. First up, Pluto. Now that the invaluable New Horizons spacecraft has moved on since its 2015 flyby, how do we keep studying this tiny, distant dwarf planet? Well, astronomers are using a clever technique called stellar occultation. Basically, they watch as Pluto passes in front of a distant star. By observing exactly how that starlight bends around Pluto, they can analyze its extremely thin atmosphere, an atmosphere that is otherwise way too far and way too small for us to see directly. And this brilliantly illustrates what they found. Comparing historical data to recent occultation observations from 2015 to 2022 reveals a distinct pressure drop. Pluto's upper atmosphere dropped by 7% and its lower atmosphere by 16%. Now, researchers are currently unclear if this pressure drop is just a seasonal change for the dwarf planet or if it marks a more permanent decay of its atmosphere. Coming back down to Earth, let's look at how artificial intelligence is acting like an evolutionary fast-forward button. Researchers have developed a new AI tool perfectly named Raygun. Instead of creating novel proteins from scratch, Raygun focuses on natural ones. It analyzes existing proteins, then systematically adds or removes single subunits, or even substitutes them entirely. It effectively miniaturizes or supersizes the protein. It's basically mimicking natural evolution to fit highly specific biotechnological needs. Being able to shrink a protein so it can fit into tight biological spaces where a normal-sized one just couldn't, that is absolutely game-changing for biology. So the crucial point is, we need to ground this excitement with a dose of scientific realism. AI editing tools like Raygun are incredibly promising, but it remains unclear if the tool will actually work on other protein families beyond the specific ones it has been tested on so far. It's an amazing start, but it's still very much in the testing phase. And that brings us to the end of our explainer today. From a 520 million-year-old microscopic cephalopod fossil rewriting the history of life, all the way to advanced AI tools literally redesigning the biological building blocks of our future, it really makes you wonder, what hidden wonders will science unearth next week? Keep that curiosity alive, and thank you so much for taking this journey with us today.